Hello and welcome to TidyX episode 67. TidyX is a screencast where we go through and explain how our code works. And as you can see, we're in person. We're here. 66 episodes.
66 quarantined episodes.
Yeah, no, this is exciting. This is our first time meeting up in person to do this, and so we're really excited to have a quick episode for y'all today. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, and you can find Tidy Explained on Twitter at Tidy_Explained, or you can hit us up on Gmail, tidy.explained@gmail.com. You can like and subscribe on the YouTube channel and leave some comments or questions, or you can open an issue on the GitHub repo, which we had this week.
Yeah, we did. We actually are doing an episode for that today.
We've put out a call for messy data after our previous... Well, we started with regex expressions, and I feel like the past three we've now gone into messy data, messy Excel data.
Yes, Excel data specifically.
And so we said, if anybody's got any messy data that they're kind of stuck on, feel free to hit us up. And so MikePrt opened up an issue with some UK government... COVID data. It looks like a pretty rich data set. He sent an Excel sheet in. It had many tabs, so we just copied out the one that he had specifically asked about. But it looks like something you probably get on like the government web page or something like that.
Most government websites. It's got a lot of information for us to kind of look at and understand. It's got so this is looking at COVID deaths, where they've got the week number and the date that the week ended. They've got this year's numbers, last year's numbers, and then it looks like some historical numbers as well, so 2015 to 2019, and then some really dense tables of information for like deaths by age group for just people in general, and then males and females broken down. And so this is, visually very appealing. You can kind of look at it and kind of get an understanding what's going on, but as I think all of us know, as soon as somebody comes up and says, hey, I want you to do an analysis on this and I've gotten an Excel sheet, this is probably what they're going to send you. Yeah. And so how do you actually get this data into a usable format for you to actually provide value?
Right. Because right now it's probably usable for the decision maker. People structure these things because I think in their head, intuitively, this makes sense. Like, yeah, we put the dates across the top and we put in this and we can look across the table. But they're not thinking of it from a potential analysis standpoint all the time. And so then they dump it on your lap. And so Mike had asked a question about this sheet, and he was kind of looking at the age groups. So there's obviously, as Ellis just went through, there's a section for all people with age groups in 5-year increments, and then males, and then females, and then deaths going across the days each week.
So everyone can see this again.
Yeah, there we go.
Yeah.
So he was kind of asking about that. So we're going to extract those three groups out and put it into an analysis data frame that can be usable.
Yep. All right, cool. So let's get going. All right, first off, we load our packages. So we load library tidyverse, library lubridate, and library readXL. So tidyverse for all our data manipulation needs, lubridate for handling some of those dates that we're going to deal with, and then readXL for actually loading in Excel data. Next, we're going to load in the actual data from the Excel file, and we're going to load it all in at once, and then we're going to actually manually parse it later. And so we're going to use the read_Excel function. This path here is to the actual file inside of our repository, and we're going to save it as .dat. And so let's take a quick head. So there's a bunch of warnings here, a bunch of, what's going on. So let's run ahead and look at what we've got. And yikes, there's a lot of NAs.
So the warnings were about the columns not having names. So it basically populated this kind of 3 dots and then a number to represent the columns because it didn't know what to do. We can see that the table that we just pulled in, I mean, it's been read in exactly like it looked on that Excel sheet, with the exception that everything that was an empty cell has been populated with an NA. So we can see, if we look at that there, we can scroll down. We see that total deaths in rows 10, 11, and 12, those are the UK for 2021, the UK for 2020, Wales, England and Wales, I think they also had. Yep, there we go.
Yep.
And then you can also see, I think, where our data, or the data that Mike was interested in, it started right around there, row 15, where it says people. And then we start the kind of age group climb in 5-year increments.
Yep, there we go.
Yeah.
There we go.
So we know where to start, and if you did the tail of the data set, you'd kind of be able to work out where to finish. And so that's kind of how we're going to
figure it out.
How we're going to go about it. So I basically did the head and the tail, and I sorted out where we needed to start and finish, and so I sliced those rows directly out. So I wanted row 5, which is going to eventually become the actual column names, because right now they're just those numerics. And then I also sliced out everything from row 17 to 80, which is representing the age group data for all people, male group, and a female group.
All right, so now we've got that data, but now we want to make our column name headers, because right now they're just contents, .2 through .55.
Yeah.
Wow.
Yeah.
All right, so what we're going to do is we're going to take the deaths data here, and we're going to throw it into slice. So slice, like we said earlier, selects out that one row. So we're going to pull that out, and we're going to call that call_names. And so these are, once again, all those values there. And we're going to just reassign that back into deaths data to, we're basically taking row 1 and setting it to be the column names.
Yeah. Mm-hmm.
Nothing too complicated there. And then we also know that the first 2 rows, or first 2 columns of deaths data is the group and the age group. So we've got that information there, so we're going to run that as well. And so this is assigning group and age group into columns 1 and 2 of deaths data. So it's kind of funny how you can do this assignment back like this.
Yeah.
At least I always think it looks funny. But
yeah. You could probably have done this in a few steps in Tidyverse. Usually when I handle column names, I tend to do it in base R like this because I want to know exactly what I'm assigning so I don't mess up any columns.
Exactly. Don't leave it up to chance.
Yeah.
All right. So next we're gonna actually remove the first row. So this is what the square brace is. It's let's remove the first row, but keep all the columns and keep all the other rows. And then we're gonna do a filter to remove any cases where the age group is not deaths by age group females to males too. So this is looking at the second column here, age group, and this is the information about the age group column name.
Yeah, and which group is being analyzed. So in the Excel sheet, it's like a repeat, almost like a repeated repeated kind of header.
And I ran the inverse just to show that there's no actual values in the rest of those rows when we have deaths by age group females. No, it's just header information from the Excel file. So that's why we're removing cases where those exist. It's kind of like what we've done in the past when we remove cases where it's like team is equal to team.
Yes.
Like when we're reading from
football reference or hockey reference, or like the combine data, right? Every 10 rows it repeats the column names. It's like body weight, name, body mass,
which
jump
is super
height.
helpful when you're looking at it from an HTML perspective, but programmatically not helpful for us. All right, so now we're gonna go and add back in. So we removed the group information, but we because it was kind of like a header, we want to add that back into the group column, and we know that there are 20 entries for each of the age groups that's there. So we're going to take our deaths data again, and we're going to mutate the group column, and we're going to add in all males and females, and we're going to use this rep function. Patrick, what does rep do?
So this is a super handy function if you want to repeat something, numbers or strings, and you have the option of repeating them either by each. So in this case, it's going to repeat each of these 20 times. So it's going to give you 20 all, 20 male, 20 female, or you could change that to times, which would then repeat that 3 sequence string 20 times, right? So it'd be 60. You could see it down there with the numbers. It'd be 60 total.
So this is a way you can kind of make your patterns.
Yeah.
Is you could, and I think you can mix the two together.
Oh, really?
And this will
So
give
now
us,
it'll give us
80.
Oh,
but it.
Interesting.
Yeah.
Yeah.
So each of these is repeated 20 times, twice.
This is a we've used this function a few times. I feel like to build like tables when we've worked with football reference or hockey reference data. The rep function, and maybe in some future episodes we'll get into this. I use this function nearly all the time when building simulations. If I'm trying to repeat sequences and things like that. The rep and sample are two functions that I tend to call pretty frequently.
Yeah. That and crossing.
Or crossing, yeah, exactly. Or expand.
Expand.grid.
Expand.grid. The old base R version, right? Yeah. Yeah, those are ones that I use a lot.
Yeah. All right, so now we've got our group information in there. We've got this, but we've got all these extra columns that don't actually have data in them. So let's do a quick view, just so you can see what we're talking about. We've got data, NA,
and then 20 at the end
and
usually.
Then, because it's got more columns here. Our
there you go. Yeah.
2020.
There, and then 2020, which I don't know why 2020 is at the end of 2021.
Magic.
But again, someone in the home office there, again, intuitively organized this and said, like, well, we know we're going to do this at the start of every week, so let's just put in placeholders, and when the new week happens, we drop the data in. Some intern is pecking away and putting the data in. Yeah, exactly. And so we need to get rid of those because they're not really providing us information that's helpful. So to do that, we're going to use this select if function. So we have our deaths data, and we're just going to pipe in this select if function. That's basically going to say if there is any NAs in the rows, let's just drop that. Let's just get rid of that. Because we know that in the deaths data, when we looked at it, if the week has happened, every one of those rows has been populated. So if there were, for example, 0 deaths in a certain age group, it gets a 0. It doesn't leave it blank because 0 has a meaningful number within the context of counting these values.
Exactly. And so this is all around contextually understanding the data that you're working with and the format, and like, does a blank mean something? Because we talked about this a little bit, and this is aggressive. Obviously, you're filtering out any columns that have an NA.
Yeah.
Another way you could approach it is finding any columns where they're not all NA, and that is going to be more conservative because it's going to only remove the columns where literally all the values are NA. And so it's just, what does it mean? What does NA mean to you?
Yeah,
and if you know it's valuable or not. In this case, we know that this is acceptable. It'll get us where we want to go.
So if you change the word any to all, we would get what you're talking about.
Yes, exactly.
So if there were an instance where, let's say, 2 weeks ago, there was no death in a certain column and it was left blank, or maybe whoever entered this data into the sheet forgot to put a 0 in, the first way we would have lost that column.
Yeah, exactly.
If we use all, that column will be retained because we see that there are values there. It's just another way to do it.
Exactly.
Yeah.
So you can do that. Alrighty. So now we've subset. Or did I actually subset?
I think you got to run it.
I got to run it still.
Okay.
There we go.
There we are. Yeah.
Alrighty. So now we've got our data subset to only have the columns that actually have values in them. Now we've got to actually, like, we still only, these column headers are still these strange numbers, which are the way that Excel stores dates, which is it's the number of days since the origin or epoch. And so it starts counting from January 1st, 1900.
1900, yeah.
Is just a strange date.
When there was no Excel.
Yes, exactly. Pre-Excel.
Pre-Excel.
PE. Yeah. Alrighty, so what we're going to do here is we're going to take this deaths data and we're going to pivot longer because we want to take it from this wide format into this long format because we want to actually be able to assign a column name to these. So when we do this, and we want to also grab all the cases where the column name is a numeric value, because we know that is then a date entry and it is reasonable to convert.
And so right now, column names are always character values. So how are you going to identify the numeric values that are potentially column names?
Mm-hmm. So what I'm going to do is I'm going to call the function call names on our data set. So dot, when you're working with Tidyverse, if you weren't aware, is referencing the data that you're piping into your function here. And so I'm going to get the column names of deaths data, and I'm going to call as numeric on it. And what that's going to do is it's going to try to convert any value, or all those column names, into a number, which will work for these guys, because these are actually numbers at the end of the day. However, these first two columns, for example, will be converted into an NA and we'll get a warning. So we can actually just call that right now there, and then we'll call it deaths data. Bow. See, it's saying, hey, yep. I accidentally converted some of these into NAs because they were character values. It's not an actual number. I don't know what to do with it.
Don't know what to do with it.
So I'm going to call it NA. And so I can use this to my advantage and go, okay, so I know that I want to keep all the columns that are going to be NA. So I'm going to call the function is.na, which returns a Boolean, is that value an NA or not? And I want the inverse of that. So that's what the exclamation point is. And then pivot longer expects a numeric entry for it. So then I call which when you call which on a Boolean vector, it returns the locations of truths. And so there's a bit of a logic train here. Patrick actually has a much more short and cleverer method to do it because he understood the data. But this way here, we're pivoting from this wide format down to the long.
We'll see the other way here when we go back to long, and we can talk about why it might work or might not work at times. But
and then now we have the dates as long. We can call the function as.date on the name value. Remember, it was still technically a character value, so we have to convert it into a numeric value. And then when you're working with Excel objects, you have to call, or numeric things, you have to tell it what the origin is. And for Excel, we know the epoch starts January 1st, 1900. However, when you're actually calculating it, you set the origin to be 1899, 12/30. So right. December 30th, 1899. And then we're going to flip it back from this long format back to the wide format so that we have the column headers be the actual dates.
There we go. And now we have our data set. So there's obviously the groups. It's going to go 20 down for all, and then it's going to start the male and then the female groups, and we've got the dates across the top. And so now we have a data frame that we can do something with. So let's build a simple graph.
All right, let's do it.
All right,
take us through this, Patrick.
Yep. So we've got our data in now in this format that's analyzable, and I'm just going to pivot it wider. And this is the other way. So we have on line 35 above, we have the clever way of like figuring out, is it numeric, is it not numeric, and looking
overthought version.
Yeah. Well, I mean, here's the thing. So what I did was I set it as column 3 all the way through however many columns that we have, with the idea being, let's say next week when we get new data in, this sheet's not going to change. It's just going to have new data, so it's going to automatically look for the final column and call with, again, as Ellis said, we put the dot there because that's how you call that data frame. The only time that this wouldn't work, having inspected the data, I knew that column 3 was going to be the first week of the year that they recorded their data. The only time this wouldn't work is if for whatever reason I changed the structure of the data and had an extra column, or the structure of the data changed under, the UK decided to report it a different way or do something like that. This isn't going to work. Line 35 is a little bit more clever and elegant in terms of it'll work no matter what you pull in. So as long as the structure doesn't change, I'm going to go from column 3 to however many columns are there, given wherever we are in the year. And I'm going to then mutate name as numeric. So I'm going to do exactly what we just did within our pivot longer data. I'm going to turn those values into numeric, or turn them into date values, because when I make this cool little plot, what I want to do is I want to have the date on the x-axis. I'll be totally honest, I got kind of lazy. I should have changed the word name to date within my, I should have renamed it. It's kind of lazy, but anyway, we're gonna take our data. Let's just pull out an age group. You could look at any age group you want. This was just to keep it simple. We're gonna go with 60 to 64. I'm gonna put the dates on the x-axis, so those are in the column called name. I'm gonna put the y on the the value on the y-axis, which is the number of deaths. I want to color this by group so that I'm gonna get 3 lines. And then we're going to just run a geom line here, and we're going to get a simple graph of the age 60 to 64 group over time, over the 2021 year. Each week there's a measurement. We could put plot or points in there or whatever it is, but just a simple way to show you that we took data that was kind of messy coming in from an external website, and we turned it into a data frame that we can now use for visualizing and analyzing, et cetera, et cetera.
And understanding and, performing the analysis you got asked to do, so that when somebody came through and said, hey, I've got this Excel file, could you mind doing an analysis on it for whatever thing they're interested in?
Correct.
Cool. And so I think with that, we got episode 67 done.
In person.
And
it was also, not only was it in person, but it was our first issue from someone other than myself. Usually I take up issues with us, but this is the first time someone else took up an issue. And so, MikePrt, we appreciate you sending in the data. This was a really cool one to work out. Hopefully it's useful to you and useful to others.
Yep, definitely. And if you have any other ideas, any other things you want us to be working on, definitely open an issue. Clearly we respond to them, and we appreciate hearing from our viewers.
Yep.
So with that, let's call it. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick. Tidy Explained is on Twitter at Tidy_Explained. We're also on Gmail at tidy.explained@gmail.com. You can open up an issue. We will read that and get back to you. Or, as always, like and subscribe on the YouTube channel and drop us a comment down there. We do read those and reply to those as well.
Yep. All right. Thank you all so much, and keep on exploring your world. Bye.